Hi, my name is Thomas Kim again. I will make a short digression. What I mean is my primary goal of this series of video is to help you create a complete scripting language. That's my primary goal. But before doing that, I will make a short digression to make you convinced that you should master Bison and Flex for your success in your life. The reasons are I will show you why. We will before we during this I will make three videos in succession that those are we will first start in-memory scanner. What I mean by in-memory scanner is that most of the time we we can analyze input from console input, either console input or file, but we will create a wide character scanner. I mean scanner that scans that analyze uh, code in C string or wide character string. The reason I'm using wide character is if we use wide character Unicode, I mean we will learn Unicode character scanner. How we support Unicode in our scanner. I will teach you that in first session. The second session we will create a window form data grid view control and use it as MFC document. And one example is something like this. We are actually, what I mean is we are creating MFC spreadsheet like, uh, sorry, I should have scanned prepared in advance. Let me see. Okay, I will skip it. This is complete spreadsheet like program, but we will create an Excel file like application in this session. I mean, we will make a spreadsheet application like this, and if we put some text, some numbers, for example, then it will be calculated like spreadsheet. We will make that kind of application during this next session, in my next video, in second video. Then we will use Flex and Bison to turn data grid view control into calculatable spreadsheet. For this three short digression, after this digression, I will go back scripting language again. So before doing that, let's get started. See, here I will prepare my previous solution again. I will unzip it here. I will use it. So go project, open solution. No. Tutorial here. This was our previous project, and we will, in current state, I will make a few changes. In Lexer, I have to make a few more change options here to support Bison and Flex included the M2 sys. Here I will make changes, and the first option should be always interactive, and then this should be no option no unistd and I need to define one macro here. Define it is, I will just copy and paste. we have to define this macro here. Then we can compile and run again if it works. Okay, it was our last session. The same. I just added a few code. I added this code because those who are using GNU Bison and Flex, they have to add these three options. Three options: 1, 2, 3. And in my case, I am using currently. Let me see here. Sorry. I'm using WinFlex, but I can use, instead of WinFlex, I can use, for example, M2sys. I will change my settings to use M2sys here. About this, please watch my previous video. I will add invariant variable here, dollar M2sys, yeah, and it should be user bin. Probably, I guess so. I have to add this. Okay, we have to add it here, and because it is debug state. Okay, I will just use. I have to copy it to release bug. I have to change it to all configuration, and this should also be all configuration, all platforms. Here, I will change it once again. The M2 sys sys2. Yeah. Of course, you have this variable on your machine. You have this. You have to define this system variable on your machine. I will talk about this. M2 sys, not M2 sys, like this. Click OK. Then I will double check my invariant variable. M2 MSys2, sorry, MSys2 DL. This is my M2 MSys2 installation for the MSys2 DL. Okay, it should be MSys2 DL. It should be MSys2. Okay. Then we change it to, instead of Win32, we change it to like this, and this also. If you are using WinBison, you don't need to change. Okay. Then let's build and let's compile and build. It succeed. Then we build all. I'm currently using MSys2. Okay, it's working. We are currently scanning from I/O. I mean from console. We will change this to something else. Okay. First, let's check our grammar here. Grammar part. We are currently using character string. Instead of character string, we will use wide character. We can of course use character string, but wide character string is more important if you are going to develop Windows application. I will tell you why. Because .NET Framework is based on Unicode system. Also, Windows, the MFC, no, these days Windows most of Windows applications are Unicode based, so we need to learn Unicode. If you don't know Unicode, now you have to learn it. Copy, and I will make some changes to support Unicode now, like this. I have changed this, and another change here, and I will disable it for the time being. And destructor, I can use the destructor, for example, like this. I have made some changes. I changed CSTR to WSTR, and this one here. Let me see if there's any error. C. I think everything is okay, fine now. Now we have to change lex here, because we changed it to WSTR. We have to change it to, like here we have to change WSTR. This should be WSTR. And what else should I change? And you should know that this scans C string. We currently implemented this function in previous video. Please watch carefully. In this class here, copy C star, it should be updated. Copy C star, because we are now dealing with Unicode wide character, it should be updated like this. WC star. We are making another function. It should be W character T, like this. Okay, and we will also change it W character T. We made two changes here. Save it. We have to save it. Then we will make this function here. We will copy it. We will change it to WCSTR and W character T. It should be W character T, like this. And this should be WCSTRELN, and this should be W character T, and this should be WCS. Okay, that's it. We will compile it first. Let's compile it. This one only. Okay, it works. And I will change it. We also need to change this. Here we will add one more. This is for C string. We will change it to Unicode, like this. Instead, we will say, I will just say W character T. Okay, we added one more function overloaded. Here we will add this function, and this will be W character T. Then this function also should be changed like this, WTOI. It is Unicode version of a TOI. WTOI is wide character version of a TOI. Okay, I've changed it. Now let's compile it once again. Okay, then now we are changing cal parser here. Let's change one more. Okay, instead of changing this, we'll make we will make instead of this, we'll say run wpass. I will say like this. File name is the same. Run wpass. We will not okay, we will just do this. No, I will change. Sorry, I will say wstr code. I will say like this. I will change it like this. Okay. I can actually use the same name because argument is different. This is double string, this is wide character string. Then here I will copy and make another one. Then I copy it, paste it, and I will change it double string. This is code text. I will say code text. Code text. Then here I'll change code text txt. Then going back, I will remove some. We will not use this. I don't know. We don't need this. I delete it, and we don't need it either. And we don't need it. At this stage, here, let me see. Here, let me check. We need to scan from text buffer, string buffer. Let's say, okay, we need a wide character buffer, W character T buffr buffer. I will make it 5 to 6 megabytes, and we will write W s print up like this as then buffer code L %s. It should be code text cstr. This converts W string to C string and writes it to here, and we missed one argument, probably SW printf. Sorry, SW. It should be SW printf. Okay, and it should be something like this. Let's check its syntax. Let me see. Character buffer, size of buffer. Okay, this should be size of buffer. The second should be size of buffer. So the size will be we have to remove two characters here. See, this is 526. This is no. We just want to remove one like this. Then we fill the buffer. Then we have to initialize it. How? We have to add two blank characters here. To do that, buffer. No, we will make a string size. Size t size WCSLEN. It gives string length BUFF buffer. Then I will do like this. Sorry. Here we have to add a 0 CL 0 character. To do that, BUFF buffer size L 0. It's very important. This is important. Then we register this buffer to scan. To do that, YYLX, we are registering this buffer to scan. INIT. Then what was it? Just a second. Scan buffer. YY scan buffer. Sorry. YY scan BUFFR. Here. Character pointer buffer. Then size. Then scanner. Sorry, I made a mistake here. Here we have to add the size. Size should be changed to size times 2 plus 1. Because this requires byte size. This is Unicode text, wide character string. So we have to times 2 and plus 1 plus 2. It should be 2 byte. Okay, 2 more byte. We have to do that like this, or you can say we can do like this. Like it's the same. Okay, we have to fix like this at this point. Then save it. Then we saved. Here we saved. Let me see. Okay. Then we will call it in main function. We will call this text. Let's see. Where is main? Function main. Here. We'll change it like this. Hello. Welcome. Unicode. Like 25. We are currently processing Unicode, not just character string. Then let's run. Sorry. Let's see what's the error message. Okay. This requires constant character. Yes, this should be, since this is double character, we have to change one more. Here we have to add one more hello say. We will change it to Unicode. Wide character string W character T. We added another one. Here we also have to add one more. Where is it? We will change it to Unicode function. Here W character T. Then it should be W. Okay. Then let's build and compile. Let's try build. We may have more error messages. Okay, another one. String copy CSTR. we prepared it. This, let me see, string copy. We created W text, so we will change it to W, but we have to change it as W character T point like this, right? Then this is W, the wide character T point. Okay, let's run. Let's compile and run. Sorry, we made a mistake here. Now this is the point. It's very important. You are now using Unicode. Unicode is composed of 2 characters. So this is ASCII character. We have to change like this. No. This is 16. This is actually means 0, null character. We have to add it to every ASCII text like this. And we have changed it. So these are 2 characters. We also have to change this. We have to make it to Unicode text. Unicode text. UTF-16 is 2 byte. It uses 2 bytes. This is 2 byte. We have to change like this. We have to bind it as parentheses, and also like this. Okay, it's perfect. Then we also have to change. We have to send a 2 byte. I think it's acceptable. Okay, it's acceptable. Then let's try it. Now we are changing from ASCII code scanner to Unicode scanner. Right. We still have error messages here. Let's see what we have to change here. Here. It is returning actually 2 byte. Instead of this, let me see. Let me check my existing code that I prepared in advance. Oh, have I changed it? Lexical analyze. Lexical analyzer. Change it. Here, INT. Say hello. Oh, this is causing trouble right now. Let me see. The rest here. Let's go back here. Scanner. OI test. Oh, we have to change it to W character T point. It is causing trouble because we are. This is Unicode text now. It is causing trouble. Let's try it. Still we have syntax error probably. Let's check it. In our code, our code, welcome, Unicode. We have to enter carriage return like this, then it will work. Suppose this is our program code, user's program code. We are scanning from text buffer. We are scanning text buffer in Unicode. For example, I can put here Korean text. I will put Korean text. 한글. Say I put Korean text here and it scans correctly. No, it cannot. It cannot. Because here, I will show you here. Lexer, this is ASCII text. ASCII text. We need to put Korean text here. To support that, I made this classification long ago about Unicode. Unicode. How can I say Unicode classification? I made it long ago, so you can use this file for your own. I will share it with anyone. So if I scroll down, where it is? Korean text is not only Korean, you have any language, right? Let's see. Korean. Hangul. This is Korean text, Korean character range, and this is Russian Kirill character range probably. And okay, I will put a Korean text here. Where is it? Hangul. It's Japanese. All characters I classified. Hangul. Hangul Jama. Okay, I will put it to my program. For example, copy, and here I say right. I can put it here, and I will put one more. Let's see. For example, Russian would be probably Kirill. Probably. I think it's probably the Russian character set. Okay, like this. Then I can do like this. This is Russian character range. And one thing more. These are definitions. So I can put let's see my previous code. Because I've done it long ago. These are letters. Okay. These are all combined. Then one or more. Okay. These are all combined like this. Then we can also all combine here. We can combine L-E-T-T-R letter here. See, I forgot the syntax. Okay. Kirill or Korean. You can actually do more things. It should be like this, or you can also add characters. Okay. Then we can do this. Instead of a character, you can say letter. L-E-T-T-E-R, letter. Okay, save it. Now Korean, our parser can pass Korean text like this. Probably also Russian. My goodness, I failed. Unicode, past 25. I don't know why it fails. Let's build once again. Lex again. Sorry, it has some error message.
You have new mail.
Warning, S option given but default rule cannot be matched. Sorry. Oh, why Koreans are not matched? Here. Here. Letter. Here. I probably need a save as Unicode. Save. Save. Advanced save option. No, it should be Unicode. Code page, probably. Save it. Now revealed.
You have new mail.
That's right. No. Anyway, this way we can scan in-memory file. I mean, instead of I will make it back. Instead of scanning from console or file, we can scan from memory, in memory. To do that, I will show you once again. You can actually download the code, and I will explain it. First, we need not this one. We need buffer to scan, then fill the buffer with text to scan. Then here, after filling, we have to, this means two bytes of 0. We need 2 bytes of 0. It actually adds 2 bytes of zeros because this is wide character and this is wide character buffer. This is wide character buffer. Wide character, it means 0. So we have 2 bytes of zeros we have to add. Then the length of this thing should be adjusted to cope with this, because character in this case size is in character size, so we have to change it. This is character size, this is byte size. Character size at this stage, but convert it to byte size. Then we create scan buffer register scan buffer. Then call YYPass. Do passing. Then destroy. The rest is the same. Also note that we changed from character to wide character. All occurrence we have changed. We actually also have to change these, but I will just leave it. Okay. In this session, I will talk more about this later. In this session, what have we learned? In this session, we made in-memory scanner using wide character, and we try to scan Unicode scanner, wide character, and we at next session I will create the WinForm data grid with control in MFC application to use it with to make a complete spreadsheet and use Bison and Flex code and calculate the spreadsheet. Thank you for watching.